When looking for a location on a map, we use a grid system, and the grid system is created using lines of longitude and latitude. So just to revise those absolute basics, a latitude line we need to remember runs from west to east, okay? And your longitude line is going to run from north to south. And what's quite important to remember when looking at a map, and this is often where students get confused, is that I've got this little key for you that you can use to remember that a latitude line runs from, pretend the top of the T is the equator line. And for us, it actually runs from the equator to the South Pole, basically being the last line. And all those little lines of latitude that run from west to east will then run in the southern hemisphere away from the actual equator towards that South Pole, increasing from 0 to 90 degrees south. So it's important to understand that even though we are using a vertical margin to cross over on these lines here, this basically the vertical margin, I'm going to use a different color, is just a marker that we use to cross those latitude lines over on. And students often get confused which margin to use when they are having to refer to latitude or longitude. So you use the margin with that is running as a vertical, but because the latitudes cross over on it, and that then allows us to read going down the map from the equator all the way down to the South Pole. Then in terms of our longitude lines, it's important to remember that the main line of longitude is our Greenwich meridian, okay? And we can then, in this case, pretend that the line of the G is representing that Greenwich meridian line that divides the world into a western and eastern hemisphere. And all the lines that then move across on the horizontal margin are moving towards the eastern hemisphere for South Africa. So they are all going to cross over like this and increase from 0 all the way through to 180 degrees east. So even though we are again using now a horizontal margin at the top, we mustn't forget the reason we are using that horizontal margin is so that our longitude lines can cross over on it and give us an actual indication as to how far away they are from the Greenwich meridian. So they increase towards the right, going from 0 degrees all the way through to 180. Now obviously on a topographic map we're not going to see such a change in degrees. In fact, our degrees don't change, rarely actually will change at all at this scale. When using grid reference, we can basically refer to two different types of references, because the grid reference is really just using a grid system to give reference to a location on a map. So all of our lines of longitude and latitude will then divide that map into a grid system, and it will either give us a block reference or a specific coordinate reference. If we look at a block reference, that gives you an indication of an actual area, an entire area, because you are creating a block over an entire region, and we then reference that block using a alphanumeric code, so either having A's, B's, C's down the one side and numbers going along the top. And so this block reference is then going to be block A1, and potentially this block where the intersection is B3. So it's important to give the letter first and then the number for this alphanumeric code. When we're giving coordinates, however, we are not giving the reference of location for an entire area. We are actually wanting to give the coordinates for a very specific feature. So X marks the spot. I want to know what is the exact position of that trig beacon. And in order to do that, we need to give firstly our latitude degree, then we need to give the latitude minute, and then the latitude second, followed by the hemisphere. And the hemisphere for the southern hemisphere for latitude is always going to be south. Followed by that would then be the latitude line that runs through the actual feature, the degree, the minute, and the second that runs through it. Then we also need to give the longitude, and that is the longitude line running through our feature. And again, you will give that by giving the degree, then the minute, and then the second, and then ending off with your hemisphere. And for the southern hemisphere, for South Africa, we specifically are going to always have a east longitude hemisphere location. And so when you're looking at your topographical map, this number here, the 24 degrees, indicates the longitude line that runs through the area. And the latitude line that runs through the area that crosses over at that point would be the 32 degree line. And we need to, you can actually extend these lines over here and remind yourself that you are drawing then a latitude line, and therefore that is the 32 degree latitude, and that for this one you were drawing a longitude line, and that then meant that that 24 degrees is the longitude that runs through the region. And so the map has then been generated along those two coordinate point markers. Running from that, we have minutes as well that have been divided. Remember that each degree is divided into 60 minutes, and generally a full topographical map will show 15 minutes of change, but the smaller parts of a map that I show, so potentially on an A4 map, we might not show as many minutes and maybe only show 5 or 6 or 7 minutes of change. So what you'll notice with the latitude first is that it starts with 15 minutes. And then we can jump down like this to the next minute line, and that is the 16-minute marker. And the next line would represent 17 minutes. Same thing happens with longitude. If you have a look over here, it's 24 degrees and 30 minutes. And if we increase towards the right, the next minute line would represent 31, the next minute line 32, and so forth. Then we know that each minute line can be divided again into seconds. So we're going to have 60 seconds that run all the way from the start of the 30 minutes to the end of that 30 minute. And then we have latitude seconds, 60 of them, that also run all the way from the 15 minutes to the 16 minutes. So we can divide these up into 60-second intervals, and we will look at how to actually use those to provide specific coordinates for a feature that has seconds lines running through it. So basically X marks the spot on that feature. Let's have a look at some examples. Our first question says, provide the block reference of the hospital that is found in Spandauwel. And if I find the area of Spandauwel, I look for the actual name, that is the area name, then I can see the symbol there for hospital is indicated. And really what the symbol is would be the actual name HOSP, and the black buildings that are rather large. You can see they're quite big black blocks, and that would indicate the region that is covered by the hospital. And so specifically we're looking for the block reference of that hospital. And so we look over here and we say that it is in row A, column 3, and so its block reference is A3. Our next question asks us to look at how many schools are found in A4. So we find block A4 by looking at the row A and the column 4. And then we need to find the symbol of the school and count how many we can find. So the symbol for school is an S. So here's 1, and then the next one, number 2, number 3. And so there are 3 schools found in A4. Right, our next question says, provide the coordinates of the toposcope that is in A1. So now what we need to do is we're going to give the exact coordinates, which are the grid reference. And that is the degrees, minutes, and seconds for latitude and longitude. We need to find firstly our toposcope in A1. So if we go through to A1, you will see that the toposcope is this little feature here, and it is labeled toposcope. And what we need to do is first mark off where does it hit the actual latitude and longitude on each margin. Now the toposcope, what you're going to do is use a ruler, and you're going to indicate on the side margin here where the latitude would actually cross over for the toposcope. And then we're going to indicate with our ruler where it hits the longitude, and that is on the horizontal margin. Okay, now we need to look at latitude first, and we're going to look at the degrees that falls into this line. And the degrees have not, haven't changed on this particular map, and so it is sitting at 32 degrees. The minute that it is sitting in is an entire block, so you can see that it starts at 15 minutes here, and 16 minutes would then start at the next line over here. And so this line here that indicates the latitude of the toposcope is between 15 and 16 minutes. It's within the 15-minute block. So if we look at it in terms of counting down, that is the 15-minute row. And so it is in the 15-minute category. Then to find the actual seconds, you need to apply a formula. And the formula that I use is I say A over B times 60. Now A is going to be represented by a distance, a measurement along the margin. You measure from this feature, or from the start of the minute block to your actual line that you marked for your feature. And you measure down in centimeters, and you measure the distance of that. And when I measured that, I specifically got 2.8 centimeters. So that is what A would then be, 2.8 centimeters. Then we're going to measure B, okay? And B is the size of the entire block. So now from the start of the 1 minute to the end of that minute. And that entire feature, when I measured it, was 3.6 centimeters. So now we say 2.8 divided by 3.6 times 60. We must times by 60 because there are 60 seconds in a minute. And the answer that I get there is 46.6 seconds. And you can round that up then to 47 seconds. And because this is a latitude reference, we go south. We're now going to work out the longitude for the toposcope. And so what we need to make sure is that we've got the position of where it hits it on that margin still there. And then we work out its degree is 24 by just looking at the map. We then look at the actual minute block that it is in. It is between the 30 and the 31 minute. So it is within that 30-minute column. So 30 minutes. And now we use the same formula to work out our seconds. And the measurement of A along the margin would start at 30, and you measure to your point. And I measured there that was 0.9 centimeters. Then we measured the size of B, which is the entire size of the actual minute block. And in this case, it is 3.1 centimeters. Remember that your longitude is often not as wide as the latitude, because when we project our maps, often we will exaggerate and distort the length going towards the latitudes. And so now when we say 0.9 divided by 3.1, the A divided by the B times 60, we get 17.4 seconds. And so we can round that down to 17 seconds. And because it's the longitude, we say it's in the east. So our final answer there for the coordinates of the toposcope is 32 degrees, 15 minutes, 47 seconds south, and then the longitude is going to be 24 degrees, 30 minutes, and lastly 17 seconds east. Let's try another one of these coordinates.
So you have to give the coordinates now for the area of erosion in B3. So if we go to B3, we can find the area of erosion. This is where knowing your symbols is very useful. Again, we're going to mark off on the actual margin, where does the center, now always use the center point in order to give your coordinates. It's not quite the center. I'm just going to try and get it a little bit more accurate. And so what you want to do is mark off where it has hit the margin here for the latitude and where it is going to hit the margin for the longitude. Okay, I'm going to get rid of some of the working out from the previous sum. So we have our latitude and our longitude features. Now we need to start off with our coordinates for the latitude. And so we start off with the degrees. It's in the 32 degree block. We then look at our minutes. If this is 15 minutes, this is 16. This would represent 17. It's within the 16-minute block because we jump down to increase. And so it is 16 minutes. And then to work out the seconds, again, we say A over B times 60. A is from the start of the minute block. We measure down and we measure that actual distance like this. Okay. And then B is going to be the entire size of the minute block. I measured A specifically as 2.5 centimeters. And I measured B as 3.6. 2.5 divided by 3.6 times by 60 is going to get you 41.6. So you can round it up to 42 seconds. And that is south because it is the latitude. Now we do the longitude. So we're going to say degrees, 24 degrees. Then we look at our minute. If this is the 30, okay, this is the 31, and this then becomes 32, and this is 33. We are jumping towards the east, increasing towards the east. So our feature is found between 32 and 33. It's within the 32-minute column. So that means that it is 32 minutes. We're then going to have a look at how to calculate our seconds. Again, A over B times 60. A is from the start of the minute block, measuring along to that line in centimeters, and I got 1 centimeter exactly. And B is the entire size of the minute block, and that is 3.1. 1 divided by 3.1 times 60 got me 19.3. And so if I round that one down, I can then get 19 seconds and east. So our final answer for those coordinates for the actual excavation site is 32 degrees, 16 minutes, 42 seconds south, and the longitude was 24 degrees, 32 minutes. We show minutes with one line, and then your seconds were 19 seconds, 2 lines, and that's always east for South Africa. Now that is if you are asked to actually provide your coordinates and you are given a specific feature. We now need to look at how to find a feature if you are actually given the coordinates in your sum. Like in this example, we've been given the full coordinates and we need to find the feature. And in order to do that, it is quite easy to see the degrees and the minutes, but it is a little bit more challenging, unless you're guessing, to find the seconds. And so the accurate way to find the seconds would be to use your formula again, but in reverse. So we were going to say A over B times 60 equals seconds. That's if we're finding the seconds. Now we have the seconds. And so what we're going to do is we're going to say the seconds divided by 60 times the size of the latitude B, and that will give us A, which is our measurement along the margin. So if we review that, that's seconds divided by 60 times the size of the latitude or longitude B, minute, and that would then give us our measurement for A. And once we have our two measurements, we can measure in the correct minute block and find the feature. So let's use this example and try and find our feature. We're in the 32 degree 15 minute row. So 32 degrees and 15 minutes is this row here. There's the 15, there's the 16. So somewhere within that row. And we have been given the seconds of 23 seconds. So if we apply this formula, we can say 23 seconds divided by 60 and then times the size of what that latitude B minute row is, which is 3.6 centimeters. So on the calculator, I'm going to say 23 divided by 60 times 3.6, and that gives me 1.37, which really means that you can measure 1.4 centimeters from the start of the 15-minute line to find A. So from the start of the minute line there, you measure down 1.4 centimeters, and that gives you the marking of where A is. Right, we use a ruler. From the 15-minute line, we know that we can then mark all the way down, and I'm going to get rid of all these other workings so that we can see clearly. And you're going to then measure, I can't measure on here because I've obviously changed the scale quite significantly, but on your map you will be able to then measure 1.4 centimeters, and that would then take you to about this position here. And that would allow you to then mark off on the margin the position of, or the distance from that start of that minute to where the feature actually can be found. And what that means is that anywhere along this, let me just get that too. Okay, anywhere along that actual latitude line is a particular feature that we're trying to look for. Now we're going to look for our longitude for this particular feature. And the longitude says 24 degrees, 33 minutes, 14 seconds. So if we apply our formula again, we can say 14 divided by 60 now times the size of a longitude B, which is a longitude minute, 3.1 on this map. And that specifically gives me on my calculator 0.7 centimeters. Okay, and so now we're going to take 24 degrees, 33 minutes, and we're going to go and find those positions. So 24 degrees is there. We want 33 minutes. If this is 30, 31, 32, 33, we're within this row or column. And then we're going to measure 0.7 centimeters and mark it off. And if I measure that, I get to about this position here. Now I know that if I bring that line down, X marks the spot, I have my feature. And specifically, I haven't drawn this latitude line very clearly, but it marks off on the bridge on the secondary road. And so the feature that can be found at those coordinates is the bridge on the secondary road, or secondary road bridge.